Okay, so we're in Geometry Unit 2, Lesson 4. Today we're going to talk about deductive reasoning. There are two laws that we have to focus on for deductive reasoning. And deductive reasoning is basically, whereas like in inductive reasoning we use the hypothesis, in deductive reasoning we use logic. So in deductive reasoning we follow a set of patterns based on given statements and facts to come up with a conclusion that is true. Okay? And remember, valid and true do not mean the same thing. So just because something's valid doesn't necessarily mean that it's true, and vice versa. The first law that we have to use, that I have to understand, is the law of detachment. And so if I have a hypothesis, P, that goes to a given conclusion, if that is true, then each part of that statement is true. So, for example, if I say, for example, if Andy plays football, he will score a touchdown. And I tell you that that's true because Andy's just really awesome at football. So let's go ahead and do this again. So if Andy plays football, and we'll go with he will win. He will win. Because he's just really good. If that's true, if that's the first sentence I tell you, and then the second sentence I tell you is Andy plays football on Saturday. What is the only logical conclusion that we can come up with? Andy will win. Now, the statement's valid. We don't know necessarily if it will come true, but we hope it will. So to use the law of the detachment, we've got to make sure we identify the hypothesis and the conclusion correctly. So, we have an example here. If a student gets an A on a final exam, then the student will pass the class. This is our P statement, and this is our Q. Felicia got an A on her history final exam. What do you think we can safely say about Felicia in the history class? Felicia will pass the history class. Pass the history class. History course. Sorry about that. Wasn't paying attention, that just popped up. Hopefully you can ignore that. Felicia will pass the history course. Now, a math example. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. Ray RS divides angle ARB so that ARS is congruent to SRB. So here is our hypothesis. Here is our conclusion. And then we started talking about ray RS. Well, that's another hypothesis. So if a ray divides an angle into two congruent angles, that's what happened, then the ray is an angle bisector. What's our conclusion? Ray RS is an angle bisector. That's the law of detachment. It's that simple. P to Q, then P, then Q. That's the 3 steps. You write a hypothesis, a conclusion, you restate the hypothesis, you restate the conclusion. Do this one on your own, and we'll see how you do. We'll check it in class tomorrow. The law of syllogism is a little bit different. The law of syllogism has to go in a specific order. And that order is, you can chain up a hypothesis and a conclusion. So if a figure is a square, that's a hypothesis. Then the figure is a rectangle. That's a conclusion. If I reuse my conclusion to get myself to a new conclusion, then I can do things in order. So if I can go from P to Q and from a Q to a new R, it's kind of like the transitive property. If P is equal to Q and Q is equal to R, what's P equal to? P is equal to R. So the conclusion that we can make is, if a figure is a square, then the figure has 4 sides. Let's see some ways that it will or will not work. If you do gymnastics, you are flexible, P to Q. If you do ballet, you are flexible. Well, ballet's new, so that's R to Q. Can we say that every person that does gymnastics does ballet? No, because we have no linking. Yes, people who do gymnastics are flexible. People who do ballet are flexible. But there's nowhere in there that links gymnastics to ballet. So there is no conclusion that'll work here. If it is 320, then we get out of school, P to Q. If it is the end of fourth block, it is 320, R to P. Is there a link? In this case it is, but is the link through Q? No, the link is through P, so that's the one that we're going to not use when we rewrite the statement. If it is the end of fourth block, then we get out of school. So we're going to go ahead and write R to Q. But we still came up with where we used each letter twice. Okay? Last example of syllogism. If Billy is allowed to get a job, then he can buy a car. So we got P to Q. If Billy isn't allowed to get a job, that's not P, then he made bad grades. Well, that's not R because we've never seen anything about that. Is there a link? No, there is no link here. We can assume that if Billy isn't allowed to get a job, that he can't buy a car, but there's not a link there for us to be able to put it together. We have nothing to relate the grades to the car. Okay. So your homework for this is to decide if the statements that are in play, and number 2 and number 3 are kind of close together, are using the law of detachment, the law of syllogism, or if the statement's invalid. I will tell you that there are 2 of each. There are 2 detachment, and there are 2 syllogism. And then there are 2 that are invalid. So I want you to try to figure out if this statement is invalid, detachment, or syllogism, and then we'll talk about them tomorrow. If it helps you, underline. Inline skaters live dangerously. P to Q. I'll finish this. If you live dangerously, then you like to dance. I'm not going to finish it over here. If you are an inline skater, then you like to dance. I'm not going to underline it. You can underline it and figure it out. Then once you've written down all the letters on the side, it should be pretty clear. If it follows this order, it's syllogism. If it follows this order, it's detachment. Do the best that you can. One of them's tricky, but then you should be able to figure it out. Okay? Any questions, come see me. Good luck.